I'm going to do a couple more u substitution ones so you can see it in action. Okay, so again, let's say I have something like this, 2x, and then in parentheses I have 5x squared plus 8. And I'm squaring that. Okay, and I have to do the antiderivative of this. Okay, so first things first, my advice. So it's 2 times all this stuff. You don't have to, but I'm going to go ahead and take that coefficient out. Again, they just sort of go along for the ride when you're doing these things. So to simplify things, sometimes the easiest thing to do is pull that thing out, and then you have x times 5x squared plus 8 squared dx. Okay, here's some things that people try to do that you cannot do, so soak this in. Don't write this in your notes. So if you're taking notes, stop taking notes and just listen to me. You cannot distribute that x inside because you have it squared. You can't distribute into a squared. Okay, so we can't do that. That method is not going to help us. All right, and there's no such thing as doing the antiderivative of a product. All right, because this is a product. You have one variable times something else, but there's no anti-product rule. So you can't just do the antiderivative of that and then the antiderivative of that and squash them together. Does not work. But I want you to do this u substitution thing I keep talking about. Okay, so listen carefully. Again, take notes, watch the video through a second time when you can actually soak it in. Okay, anytime you have something that's chunky taken to an exponent, I want you to do u substitution. Whatever's in those parentheses, that's what you're going to call u. So my u in this case equals 5x squared plus 8. Okay, that's my u. And you might be going, well, what about this x? Well, we'll take care of that x in a minute. So right now what we've simplified that equation to is we still have that x, but now we have this, instead of this parentheses being squared, we have u squared dx. Okay. So now my goal, you can look at that. If you'll start simplifying or substituting in the middle of the problem, you can see, okay, I've got an x and a dx. I need to know what that is in terms of u, but we're getting there. So step 1, take what's in parentheses, call it u. Step 2, now do the derivative of it. Derivative of u is du. So that's your implicit differentiation. Derivative of 5x squared is 10x. Derivative of 8, oh, we should put dx. We always put the d of our variable. Derivative of 8 is 0 because it's a constant. Okay, so now again, I need to know what x dx is. X dx. Well, here's x dx. So just get rid of the 10. So move that 10 over. Remember what I told you about rewriting it? Rewrite that as a coefficient. It's easier. 1/10 du. That's what x times dx is equal to. So now my substitution looks like this. Okay, so I have this u squared that I'm bringing down, and then instead of x times dx, I'm going to write its new definition. So whenever I have x times dx in this problem, that's the same as 1/10 du. That's your direct substitution. X dx, x times dx, and you might be going, well, I don't have them next to each other. Yeah, but you still have them times each other. The order that they are being multiplied does not matter. If you want to rewrite that so that it says u squared x dx, you can. That might be easier for you. So 1/10 du is what I've substituted now I look at my problem. I have nothing but u's, so now I can simplify it. I'm going to take that coefficient out. Just makes my life easier. So when I bring the 1/10 out, I got 2 times 1/10, which is 2/10. 2 times that 1/10 that comes out. U squared du. Okay, now do your antiderivative. It's nice and simple. I have no parentheses. I have no products. I just have one of the most basic antiderivatives we can have. Add 1 to your exponent. Divide by your new exponent. Plus my little random constant. But I do have to remember I have to multiply that thing times my 2/10. Since this is just any random constant, multiplying random constant by 2/10 is still just some random constant. So you just leave it as c. Whoa, that didn't move the whole thing. Okay, so that gives you 2u cubed over 30. And I'm going to reduce that. 2 cancels out with 30, so you get u cubed over 15. That is not my final answer because my problem was given to me with x's in it, so I have to put the x's back. So go back to your definition up here where you defined u. And so instead of having u cubed, you're going to put its definition, whoa, you're going to put its definition back in its place. So your final answer, now I got to move everybody. Oh, it won't let me move, so I'll scoot it. Your final answer would be u cubed, so that's 5x squared plus 8. Remember, that's the definition of u, and it's cubed, over 15 plus c. That's the derivative.